Welcome back to our neuron simulation project. Last time I said that we're going to implement interaction into the process. That's what we're going to do. But to make this work we need an accurate neuron structure model. If you look at our visualization, how the fuck am I struggling with this?
Visualization.
Sorry, I'm Austrian, I will try my best. If you look at our
Visualization,
you will see that we only got a single connection type for the branches. To make an interaction logical possible, we are going to need a second one, because real neuron connection lines consist of dendrites and axons. But we only got dendrites. They only are capable of receiving signals. Axons, on the other hand, are able to send signals. And as I said, we are going to need both. To fulfill this quest, we only need to copy the code from our dendrites, simply because they both work the same way and grow in any direction. To be precise, the axon will take over most of the tasks and functions the dendrite had before. I also changed some thresholds to make it more realistic, because dendrites often don't get as long as axons. Of course, I also changed the colors to differentiate them. To take our first step towards simulating a neuronal interaction, I will expand the nucleus of our neuron if the origin, by which I mean the entire neuron, has at least 3 connection points, or more precisely terminals, just to make the simulation feel a little more alive. I do not know how, but I failed a little bit at this task because I picked a wrong list in the code. And somehow I messed up the whole simulation. So that you know roughly what the main goal is, we are trying to create a realistic replica of neuron formation. This is what neurons actually look like under the microscope. When I wrote all the code and went to sleep that night, I realized how to solve the messy branching problem. I never really was satisfied with the result of dendrites branching, now including the axon, because they grew into a large mess of snail rolls. See? I fixed this issue by simply counting the structures in the range of 2. Only if the number were less than or equal to 2, they would be allowed to grow in that direction. And as you can see, it works. Now I can finally rest in peace. Moving on to the signals. The goal is to track a single neuron and to observe which properties of the signals change when contact points are established. There will be the ping, frequency and the impulse energy property. Based on the number of pings, or basically terminals, the frequency and pulse is derived from it. I will implement probability so that external influences can be recreated. For a better overview, I also changed the GUI with the info text. The full functions of the interactions are presented below. In this case, we are now observing the first origin. As a future goal, signal processing could be included, but overall we have improved or created many basic functions today. I think it's time to look at the result. If you want to play around with this simulation, you can check out the GitHub repository in the description below. I would be extremely happy if you could leave a like if you enjoyed the video. I'm trying my best to improve the quality of the videos every time I post something new. I also want to thank you for all the positive comments and feedback, and I hope I will see you next time.